Welcome to Problems and Solutions. Today we will solve problem 99 of Tipler and Mosca, Physics for Scientists and Engineers. A rock is thrown from the top of a 20 meters high building at an angle of 53 degrees above the horizontal. Item A. If the horizontal range of the throw is equal to the height of the building, with what speed was the rock thrown? B. How long is it in the air? C. What's the velocity of the rock just before it strikes the ground? Ignore any effects due to air resistance. So I already draw the situation. The rock is thrown from the height of the building, and the height of the building, here I use the 8 to represent this height, is equal to the distance reached from the distance the rock reaches. And so let's solve the problem. It's not so difficult. Let's write the equations and then we solve the problem. First, in the x direction, we have a uniform motion. Therefore, we can write that the velocity, here we have, or better, the displacement in the x direction will be 8, the total displacement. Okay, let's write before the total, let's write the equation of the movement in the x direction. X equals x0 plus the initial velocity in the x direction times t. This is the equation that represents the movement. If you consider the total displacement in the x direction, we can write that h equals the initial velocity in the x direction. It's necessary to project this v0 with the angle theta. Theta equals 53. So we'll have v0 cosine of theta, this is the initial velocity in the horizontal direction, times the total time. Let's represent with a letter f, the time to reach the final situation. Therefore, the total time will be 8 divided by v0 cosine of theta. Now let's write the equation for the vertical direction. We will have the height will be the initial height plus the velocity, initial velocity in the x direction multiplied by time, minus g, the gravitational acceleration, divided by 2 multiplied by time squared. And if you consider the final situation, the height will be 0 and the initial height will be epsilon 0. Therefore, we can write 0 equals h plus v0 sine of theta multiplied by the total time, we are considering the final situation, minus g divided by 2 multiplied by the total time squared. Now if you take the final time or the total time and substitute it in this equation, we can isolate v0 and find the velocity, the speed, the initial speed, or the speed with which the rock is thrown. Therefore, you can write A. Let's do it. Let's substitute this total time here in this equation. 0 equals 8 plus V0 sine of theta multiplied by 8 divided by V0 cosine of theta minus G divided by 2 multiplied by 8 divided by 0 cosine of theta squared. Okay, we can cancel this V0. Here we have sine divided by cosine, that is tangent. So we'll have 0 equals 8 plus 8 tangent of theta minus, here we have G 8 squared divided by 2 V0 squared cosine squared of theta. And also can cancel this 8 with this square. Therefore, we will have D multiplied by 8 divided by 2 V0 squared cosine squared of theta equals 1 plus tangent of theta. Tangent of theta. And we want to isolate V0. Therefore, we can write that V0 squared will be G multiplied by 8 divided by 2, 1 plus the tangent of theta multiplied by cosine square of theta. And now we can substitute our numerical values, and we'll have 9.81. Here the height will be 20 meters divided by 2 multiplied by 1 plus the tangent of 53 degrees multiplied by cosine squared of 53 degrees. And we can use our calculator to compute the velocity. So let's do it. 9.81 multiplied by 20 divided by 2 multiplied by 1 plus the tangent of 53 multiplied by the cosine of 53 squared. Yes, this is the square velocity, so let's take the square roots, and here we have 10.89 79 meters per second. This is the initial velocity, the velocity with which the rock is thrown. Letter item B. Let's see. how long is it in the air? Here, what we want in this item B is the total time. Therefore, we can copy this. Let's copy. Okay. So it's the total time in the air will be 20 meters divided by 10 meters, 0.79 multiplied by cosine of 53 degrees. Here we want 20 divided by 10.79 multiplied by cosine of 53. 3.08 seconds. This is the time the rock will stay in the movement, in the air. C. What's the velocity of the rock just before it strikes the ground? Okay. Item C. Here we have a velocity in the horizontal direction. It will be V0 cosine of theta. This velocity won't change during the movement. We don't have any acceleration in the x direction. Therefore, the velocity in the x direction will be the speed 10.79 multiplied by cosine of 53 degrees. So we will have 10.79 multiplied by the cosine of 53. 6.5 meters per second in the x direction. Now the vertical velocity will be V0 sine of theta, that is this is only the initial velocity, but we have also the acceleration minus the acceleration multiplied by the time. We want to know exactly before the rock reaches the ground, so we will use here the total time. Therefore, we'll have the velocity, vertical velocity will be 10.79 multiplied by sine of 53. Let's here minus 9.81 multiplied by the time 3.08. Therefore, the velocity in the y direction will be 10.9 multiplied by sine of 53 plus, or better, minus 9.81 multiplied by 3.08 minus 21.6 meters per second. Therefore, the velocity will be 6.5 in the x direction minus 21.6 21.6 in the y direction in meters per second. And that's it. The problem here, item A, item B, and item C. The problem is solved.